1.7 Selecting procedures for limits. This is an important algebra identity to recall in this lesson. If you have a minus b times a plus b, that's a squared minus b squared. Again, first thing you want to try with limits is try direct substitution. If you plug in 5 for the x's here, you'd end up getting 0 over 0. And we cannot factor this like we've done before. So this method here is rationalizing the fractions with radicals or conjugating the root. So you can think about this root here as your a, the square root of x plus 4 as your a, and the minus 3 as your b. And you can multiply it by the same thing just with a plus instead. Square root of x plus 4 plus 3 over the same thing. Square root of x plus 4 plus 3. So what happens on the next line is if you rewrite this, limit as x approaches 5, it's a minus b times a plus b. So if you square the square root here, it's just x plus 4. I want to just do that in parentheses because it might make sense a little later. It'll help. And minus 3 squared, which is just 9, over the bottom is just x minus 5 times parentheses square root of x plus 4 plus 3. So if you notice here, x plus 4 minus 9 is x minus 5 on top. X minus 5 on top cancels out with the x minus 5 on the bottom. So that just becomes the limit as x approaches 5 of 1 over square root of x plus 4. Sorry, that should be a 4, not looking like a 9. X plus 4 plus 3. And now if you do direct substitution, you get a 1 over square root of 5 plus 4. It's 1 over square root of 5 plus 4 plus 3. And if you do it, it'll be 1 over, well, root 9 is 3. 3 plus 3 is 6. So you get a 6 right here. The second problem, you can feel free to pause and try this on your own. But you want to multiply this by, you see the roots on the bottom. You want to multiply it by a 3 plus square root of x minus 1. And the same thing on the top, 3 plus square root of x minus 1. And then you can rewrite the limit here. Limit as x approaches 10. We can do the bottom first since that's the a minus b times a plus b. That's 9 minus, this is why the parentheses now is important, minus parentheses x minus 1. Because you're subtracting this entire radical here. The parentheses is important because if you don't have it, you're going to get wrong negatives where they shouldn't be. And then you can just leave the top what it is, x minus 10 times 3 plus root x minus 1. And just for more room here, I'm going to rewrite the bottom here. Limit as x approaches 10 of x minus 10, 3 plus root x minus 1 over 9 minus x. If you get rid of the parentheses, it's 9 minus x plus 1. Let me just show here. 9 minus x plus 1, which is equal to 10 minus x. So if you can write it as a negative x minus 10. 10 minus x is negative parentheses x minus 10. The reason we're writing it like this is because you see we do it like this. The x minus 10 will cancel out. And then what we're left with here is the limit as x approaches 10 of 3 plus root x minus 1 over negative 1. Because 1 over negative 1 there, and then you can try direct substitution now. It's 3 plus root 9. Well, 10 minus 1 is 9 over negative 1. 3 plus root 9 is 3 plus 3 is 6. 6 divided by negative 1, we get negative 6 right here. All right, so this bottom part here now is with complex fractions. This is something students struggle with sometimes a lot, so it might take some more time, but let's get through this here. So we have limit as x approaches 0 of x over 1 over x minus 4 plus 1/4. And we want to pretty much solve this fraction here at the bottom to make this into one term. I'll show you what I mean right here. That's the same as the limit as x approaches 0 of x over. So here you want to have a common denominator. So it's x minus 4, the denominator here, the denominator in the other fraction here is a 4. You kind of pretty much like cross multiply. So this one here, you multiply 4 and 4 in the top and bottom, and here you multiply x minus 4 over x minus 4 on the bottom. You just multiply by what's in the denominator of the other fraction. So that gets you a 4 over 4 times x minus 4 plus x minus 4 over plus x minus 4 over 4 times x minus 4. And then you can combine these fractions here. Limit as x approaches 0 of x over common denominator. You can just add the numerators together. So it's a 4 times x minus 4 here. Sorry, I keep writing my 4s looking like 9s, but it's a x minus 4. And then a 4 plus x minus 4 is just x here. And then, if you recall, it's x divided by this whole fraction here. And if you divide fractions, that's the same as multiplying by the reciprocal. So it's x times this fraction here reversed. 4 times x minus 4 on top over x. You see here there's an x on the top and bottom. They cancel out. And you're just left with the limit as x approaches 0 of 4 times x minus 4. Now you can just plug in 0 for the x. That becomes 4 times negative 4, which is equal to negative 16. Fractions, fractions, fractions again. If you need more assistance with this problem, please ask your teacher. They will go more into depth with you, but these are skills that are going to be really, really important. Not just for your AP exam and success in this course, but also colleges will be expecting you to know how to do fractions. So if you need help, don't be afraid to ask. Otherwise, they'll hurt you later on. So we're going to do this last example here. So similar thing with this problem here. We just want to kind of rewrite this top numerator here. So with this left fraction here, you multiply the top and bottom by the denominator of the other fraction. So you multiply the top and bottom by 9. And then for this fraction here, you multiply the top and bottom by x plus 3 squared on top. And multiply the bottom by x plus 3 squared on the bottom there. So rewriting the whole thing, limit as x approaches 0, that gets us, let me just do the over x on the bottom here, because that stays the same. And just to save a step, the common denominator is going to be 9 times x plus 3 squared. And now let's just rewrite this on the top. 9 minus parentheses x plus 3 squared, just to save n, x plus 3 squared is x squared plus 6x plus 9. If you're not sure how we got that, please ask your teacher and we'll clarify it if you forgot from Algebra 2. So now if you rewrite this again, limit as x approaches 0, what do we have here? You see, well, instead of divided by x, we can just have this all multiplied by 1 over x. And so here we'll still have the 9 times x plus 3 squared. This is just to make it a little more organized. Instead of divided by x, just multiply by 1 over x at the end instead. So 9 minus x squared minus 6x minus 9. The 9 minus 9 cancels out. You're left with minus x squared minus 6x. And then from here, what you can do is, if you want to rewrite this again, I'll do it over here. Limit as x approaches 0. You can factor out an x here. Negative, because x times negative x is negative x squared minus 6 over 9 times x plus 3 squared times 1 over x. You see the x and the x will cancel out on the bottom, top and bottom. So then now you're left with, after crossing these out, you're just left with negative x minus 6 on top and 9 times x plus 3 squared on the bottom. Now you can just directly substitute in 0 and you'll get your answer because you've canceled something out on the top and bottom. Negative 0 minus 6 is just negative 6, and then 9 times 0 plus 3 squared. That's negative 6 over 9 times 9, which is 81. You can leave that as your final answer or simplify it if you want. That's your choice. Thank you very much.